Yeah, I hope all of you know. I you can know me, but still, I'll just introduce myself. I'm Vichender. And I'm the one going to be talking for the rest of the session today. So, at Alumnex AI Labs, we started this new series where we call it the Code to Crop, kind of an initiative. If you see this Code to Crop, right? Basically, the idea is we are building agriculture agri-tech product, okay? And while we're building this product, we are actually collecting data from the field and solving some problems, okay? So we have a kind of a Mozambique farmer who's tied up with us, and he wants us to solve a real-world problem where he wants us to detect the total number of Mosambik plants on his farm, which is a 10-acre farm. Okay. Um, so what we are doing as a start, because his farm has, is around 250 kilometers from Hyderabad, and it's not easily accessible, right? So what we are doing is we have gone to a farm which is my farm pretty much, right? So it's just a half-acre farm which has some mango plants on it, and an assorted set of other plants like pomegranate, guava, and other stuff, right? So we are collecting as many images as possible to solve a real world problem, to see if we can build a model which can detect the count of the mango plants on my farm. There are roughly around 90 plants, uh, and I know the exact count, and I want the model to be able to determine it exactly. Okay, so that is the problem statement we are doing. Where in this series of 5 sessions, I'm going to share the data, okay, of all the images from my farm, and I'm going to um, make sure that I share them with you. I'll teach you some of the theory behind how it happens. How do we build a model? What are the various options available? And we will actually build that model and train it and test it on Mango, right? As a next step, right? Again, those who build this model successfully, and they are able to deploy it successfully and showcase it to me. I will have a quick 15-minute interview with them to understand, did they really do it, or did they just copy something and just took something from my code and wrote it, or they actually understood the subject. So for the select set of people who kind of pass that interview stage of mine, 15 minutes only, or maybe just 10 minutes, we'll give a certificate of completion where I'll say that you are pretty good in this particular use case, right? This project you can put in your resume. And I will give those select folks a chance to work on the Mozambique model detection. So that will be the one which will actually be deployed on the farm of, there are 2 farms actually now. Another person also came. So he said he also wants help on that. So I said, okay, sure. If you build one model, I think it should serve 2. And it's like applying the model in real world, guys. Okay. So most often than not, I think a lot of us work on building models which are, which we just don't use anywhere, right? So sometimes I've seen people, some projects when I do interviews, right? I take a lot of interviews, and I see some people, they say tuberculosis detection using, some model they've built, right? And they say it's 97% accuracy, right? So I say, you know what, are you sure if this is that good? If would you apply to yourself, right? Touch wood should not come. But if something did happen, would you apply to yourself? And then the immediate answer is no. Okay. So the problem is, the majority of the times these models are built just as academic exercises, and they stand no weight, correct? So that's when I thought, let's kind of build the real deal, build the real projects, and solve it together. Okay. Now a lot of these things, again, we will run into rough weather. We will not be able to go beyond a point. It's going to happen. Okay, trust me, it's going to happen. And I need help from all of you guys to help us in solving some of these problems. Okay. So we will kind of show a banana, and even our best model will still say it's mango, right? Now I need your help in kind of solving those problems as well. So, right. So I will provide the entire data set. I'll provide the access to the entire data. And if you guys want more data, you can ask me. You can say, you know what, I think this is not working. I think for this model to work, I think we need this resolution of data, or more, image. The drone should capture images at a much more granular level. Feel free to let me know. Okay. So it's as real world as it can get, guys. And you folks are going to be part of building the next big model of for farmers around the world. Okay, at least in India. Okay, not around the world. Okay, so let's get going. So I already introduced myself, and in today's section, right, we are going to talk about introduction to computer vision. Okay, we're going to talk about the classical computer vision approach and how we are using deep learning. What's the new approach using deep learning, and we'll talk about object detection. Just one second. Yeah, this fan is making a lot of noise. So then we will talk about object detection for counting and choosing the right approach, and then we build a basic model. Okay. So that's what we're going to cover in today's session. A lot of stuff to cover. So let's get going. Okay. So before we get going, anybody has any questions? Just quick thought. Just
Hello.
wanted, yeah.
ఏడున్నారా? కాదు ఒకసారి ఆయన ఫోన్ చేసి కొట్టమని చెల్లి ఆడు కొడతా అన్నాడు మళ్ళీ ఫోన్.
Okay. So before we get going, does anybody have any quick questions? Anything to ask or anything on the what we are trying to do or anything? Quick, yeah. Rohit, let's see. What do you have?
It's for me, computer vision is new, so I just know we use video with the help of computer vision.
Correct.
We are able to access video stuff to the machine learning model.
Correct.
But apart from that, I don't know anything pretty much. But during the course of this 1 week, will I be able to do something out of it, or have a 15 to 10 minutes with you? Like, I'm asking you, like, will I be able to learn something?
Yeah. So yeah, I'm sure if some of you might have these questions, right? So computer vision is new to a lot of people. Okay, so most of the people, they focus on language models, or and so computer vision is something new, but don't worry about it. Okay, I'll teach from the basics. Okay, so just follow through. I'll teach from the basics. In fact, you should be able to follow through even if you are a beginner, absolute beginner. Don't worry about it. Okay, so that's why today's session is not going to be heavy. I'm not going to write heavy code. It's going to be as basic as possible. So most of the people who attend my sessions, they know it. I pace it out, so you know that it's easy to get through, right? So you should be able to build your own model by Friday, right? That's the idea. Okay, yeah, but you have to put effort. Okay, I hope that answers. Next question, Sohit.
Hello, sir. I have a doubt. Is CNN a part of
Yeah, Sohit, I can't hear you.
computer vision?
CNN a part of computer vision? Is what you're saying?
Yes,
Is
sir.
what the
I
question
have a
CNN?
doubt regarding it. Yes.
Yeah.
Yes, sir.
Yeah, CNN is one of the CNN is one of the several approaches for computer vision. Yes, it helps to solve. Yes, yeah. I'll talk about it. Right, we'll talk about all of these going forward. We'll also talk about YOLO and some of the other things. Okay, but again, we'll be more focused. I will touch everything. I'll touch all these concepts, but we'll be more focused on solving a problem. Okay, so that we just don't learn something random and leave it there. Okay, so by the end of Friday, I want you guys to build the models. There will be problems along the way. I want people to solve them, find solutions, and that's how we build these sessions. Okay, it's not that I have solved everything and come. I may also have some problems. I took an ImageNet model, retrain model, and we have built something. I don't know if the accuracy is great. If some of you guys can help me improve the accuracy, awesome. Okay, so that's how these sessions are structured. It's not like one of those boring run-of-the-mill sessions where you just start taught something and you just copy paste the code and you run something happens and you don't know what next. It's about solving a real world problem. And if I give a new image, I want a very high confidence level to say that this model is working. And that's when we apply to the Mozambique. Okay. Yeah. Go ahead. Anybody? Karthik, you have a question?
Yeah.
I have a doubt. Where can we get this recording lectures, sir? So that we can refer it further.
Yeah. So all of you guys, there is a portal. Okay. We built an internal dashboard. It's called. I'll just put it over here. So you can again check it later on, but I'll still share it. almex.com/project-school. Okay. So I'll put this recording there. Okay. So you can access later, guys. Don't worry about it. Okay. Let's get going. Anything related to the session, course session, guys. Let's ask. Satvik, any question?
Yeah, actually, in the third slide, you have mentioned about deep learning, image classification with
Yeah.
respect to deep learning.
Yeah.
Like, we have also been taught about KNN algorithm, which is of ML, which is a topic of machine learning.
Hmm.
So why cannot we use machine learning instead of deep learning? Since we already know how the crop is going to be or something. So why is deep learning going to be in the picture?
Yeah, correct. So that's right. So actually, yeah, I think it's a little bit advanced question for the others, but I still answer. See, their traditional way of computer vision was, using manual process, right? You actually define the rules for how you identify your images, correct?
Yeah.
But deep learning basically says, I don't need to do anything. Just give it 25, 30 images. It automatically learns by itself, right? So you don't have to write rules or anything. You just, the more training data you get, the better model you use. It learns by itself. That's the benefit of deep learning, correct? It reduces the kind of manual process you need to make, or manual effort that you should take earlier on, to kind of learn automatically and kind of give you. So in fact, I'll just show you, right, using one tool, using teachable machine. I'll show you how easy it is to just dump in some images and learns, and that's it. Brands you set up images it has never seen before, it just learns on the spot. You've not written a single line of code, and I'll show you that. Okay, that's a benefit of deep learning. Okay. um okay, any other questions? Or okay, we'll get going, guys. Okay, let's park the questions for the end. Okay. So don't worry about recording, you will get it on that this dashboard which I've shared the link on. Okay, I'll just put the hyperlink on this. So it will have the recording, and it will have the details of Discord channel and all that, which you can access. Okay, I'll talk about it towards the end. So let's get going, guys. Okay. So introduction to computer vision, right? So computer vision basically is that field of, again, of AI, which enables machines to interpret and process visual data, correct? Now, why do I need to have this kind of branch of AI to do this? Because manually it may not always be possible for us to kind of do some activity. Why not give it to a model, a machine, by training a model and giving to the machine to do that job? Simple example, I'll tell you. Let's say you have a traffic signal, okay, and each traffic signal, I'm sure all of you guys know about traffic, right? Not all junctions have the same set of traffic inflow and outflow, right? Like, some of them might have a huge number of vehicles coming in, some of them have a less inflow coming in, correct? So the inflow at each of these four points in the traffic signal will be different, correct? So how do you identify that? How do you identify how many vehicles are coming? So you just have a simple camera there, and you design your computer vision model. It can be a YOLO model, right? It kind of just keeps counting how many are coming continuously, as in how real-time streaming, correct? So it defines a bounding box. It defines how many cars are coming, and then it automatically gets a count, correct? So then that you use that data continuously for a matter of 30 days or something, and then you say, what is the density, right? Traffic density is how many vehicles are flying in that junction at that for that given duration of time, correct? For, like, say, 1 hour, what is the number? You take an average of all those data points, correct? So then you compare it against all the four junctions, and you see which one is the one which is kind of having high. How should I give more time, less time, and all that? So again, computer vision has a lot of applications, right? It can be as simple as, again, your image barcode scanners on your cars, right? And again, I don't want to get into this, it's enormous. One of them is, of course, our problem statement, which we are trying to solve in terms of determining if a particular image of a plant has a mango tree or not, correct? So the third one is, of course, the use case on this. Okay, so the core tasks of computer vision, again, there are a lot more, but the core things are image classification. That's one. Second thing is object detection, and third one is segmentation. Okay, so it's part of the, again, image classification. Again, it's part of supervised learning. Okay, and we are going to see what exactly all these are. So it's important to understand the difference between all these three types. Okay. So classification, object detection, and segmentation. So these are the three things you should know. Again, there are other things like object counting and object tracking and on all that stuff. But pretty much, again, for your interviews or most of the times, what people are asked is, do you know the difference between these three? Okay, specifically from a computer vision perspective. So classification is a basic classification in supervised learning, right? Which class does it belong to, right? Is it a mango or is it a banana? Or not a mango? It can be as simple as that. Is it a mango or not a mango? correct? So all these images are from my farm only, guys. Okay, so all real images. There's nothing from Kaggle. It's all from my farm itself. So we've taken up using our own drone. We have actually taken our own drone and flown it on our farm and got these images. So the images which I'll show later on also are all real images. Okay. And if you guys want more data, you can let me know. We can get more data, right? We have a drone and we can fly it if you feel that it will improve the accuracy of the model. So next thing is, first is classification, second is object detection. Object detection, basically we are saying within that particular image, where exactly is the plant, correct? So if I have, let's say, an image which has a cat, a dog, right? Where exactly in that image is the dog, correct? It also, that's detection. Then the third one is segmentation. Segmentation basically says, I want you to draw the boundary, correct, of where that particular object is, okay? So basically, if you see, the third one you're seeing, it's having that faded green color, right? So it's basically saying this is the boundary of the object that you are interested in. So typically, if you have a person in a particular picture, the segmentation will say it will just draw the outline of that and fill it with some color. It is not going to show you the bounding box, or it's not going to give classification. It's going to draw the outline of that person and fill it with some color and say that this is this particular segment that you're looking for, right? Or human, right? So that's what is the key difference. Okay, classification, object detection, segmentation. So each problem statement again will have different models, right? You'll have to use different models for different use cases. Like for example, YOLO. YOLO, YOLO is basically used for object detection, right? You train it on a lot of images which contains these bounding boxes, and it learns from there, and you give it a new object, it will tell you exactly where that particular object is located within that particular image. Okay, so that's YOLO, and again, each one will have its own thing. We'll come to that later. So classical computer vision approach. Like, what is the classical way of how computer vision was approached? So one of the things in computer vision is called OpenCV. Okay, it's one of the classic frameworks, which is like how do we check it? Like, it can be like NumPy and Pandas, right? Typically, when you build applications using most of the Python applications use NumPy and Pandas, right? You use like so. Just like that, it's OpenCV. OpenCV is very powerful for the computer vision. One of the beautiful frameworks which lets you do a lot of image processing, right? Just like you see, you want to open a CSV file, right? In suppose you had a CSV file and you wanted to read the contents of the CSV file and do some aggregation of one particular column, correct? Typically, how would you do it in Java, right? How do you do it in Java? You would kind of load a particular library, and then it will fetch the data and into some store it in a variable, and then you loop through that variable and do all that drama, right? So imagine how do you do it in Pandas? You just say pandas dot pd dot whatever read CSV or something, and just reads it, and then you say dot total, that column name, and boom, that's it. You get the value, right? Just 3 lines of code, you get the average of that particular column that you want, right? So that's the beauty of Python, and that's why Python has become so powerful in number crunching and statistical analysis, correct? So again, what is facilitating that in Python, right? The pandas library is facilitating that, and of course NumPy is again going to do further analysis on the arrays and single dimensional data and all that. But here, if you look at it in computer vision, just like the equivalent of pandas, you have OpenCV. It just goes and does. It's the same equivalent of pandas. Just like pandas is strong for number crunching from CSV files, you have OpenCV for images. Okay, so OpenCV basically what it does is it will allow you to pull an image. It will allow you to do whatever you want with that image. You want to compress it, it'll do it. If you want to apply filters, so most of you, I don't know how many of you use Photoshop, right? Or even if not Photoshop, you might have used some kind of image filters, right? In your phone, you would have taken a photo and you would have applied grayscale or made it, whatever saturation, hues, and do all that stuff, right? So you can do all that using OpenCV, correct? So, for example, it can do pre-processing like color filtering, like I just said, HSV. You can also remove noise, okay? And you can extract features. So one of the things that we do commonly in OpenCV is you kind of just get the edges, right? You apply the front filter, which will just get you the edges of that particular image so that you can clearly see what that image is, and you can determine that image. So before you process images, you generally run it through OpenCV and then process the images, okay? So, again, OpenCV is this. Let's move on. The next thing is image classification with deep learning. Okay, so again, traditionally, again, why we saying classical computer vision approach, OpenCV was the classical way how it was done, right? Typically, if I want to determine a particular image in a particular object in a particular image, right, what would you do? You define rules, like, you say if this particular the curvature is so and so, or the distance between this and this is so and so. You write that particular logic to say OpenCV is going to be used like a workflow kind of thing to determine, right? But it's pretty, what do I say? Simple cases it works, but when it's pretty effort taking, right? A lot of effort to do that. So that's when deep learning really came and changed the game, correct? Deep learning said, it learns the features automatically from raw pixels. It just says, give me 20, 25 images and I'll figure it out. Okay. Now, if you see, again, if you compare it with the LLMs, right? Today, most of the LLMs are not like you program them specifically, right? They say that nowadays, they say these LLMs are learning by themselves, right? So that's the beauty and power of this. You give them like millions of, lots of GBs of data, petabytes of data, and then they kind of initially you're training them to learn, and then gradually they start learning by themselves. So that's the power of deep learning, and that's where it made a huge change, correct? In terms of how we approach computer vision. And of course, you have mobile VNet, mobile net V3, you have efficient net, you have a whole bunch of other models. So these are all pre-trained models. Some of them are pre-trained models. So you again can train your model right from scratch up, or you can use some pre-trained model. Okay. So for example, one of the things is again YOLO. YOLO V8 is a pre-trained model which is trained on the. Can someone tell me what is it trained on? YOLO. I'm sure all of you might have heard of YOLO. Some of you who have heard of YOLO. It's trained on which data set? Anyone? You can put on chat if you cannot talk. Can someone tell me what is YOLO V8 trained on? YOLO V8 is one of the best models, pre-trained models to work in computer vision for object detection. Does anybody know what data set is trained on? Any guess? Okay, I'll tell you. Any guess? Anybody wants to take a guess? How many of you heard of YOLO V8? How many of you? Yes, that's right. That's Coco. Coco, that's right. Yeah, Pawan and Hema Vignesh, you're right. So it's trained on the Coco V8. Yeah, you only look once. Yeah, that's correct. But it's trained on so that everybody knows. YOLO full form, everybody knows, but a lot of people don't know what's it trained on. So Coco is trained on the Coco dataset, and basically Coco dataset has around 80 classes. Okay. So see, if you see here, it said 80 object categories mentioned here. So if you are using YOLO for any of these 80 classes, you really don't have to train it again, it'll work. Okay. But if you are doing something new, like we are doing mango detection, I don't think it's there in that, correct? So so again, that's why YOLO will automatically help you with people detection and all. You don't have to extensively again train it for that. So you can just use it for your people detection and all other stuff. Okay. So because it's already been pre-trained on that. So that's with YOLO. And what again we can do is if you don't want to use YOLO and all, you can actually use some of the other models like mobile net V3, efficient net. And what we do is something called transfer learning. Okay. So again, I'll go into transfer learning and all the others in the subsequent sessions. I don't want to kind of overwhelm you today. Okay. So basically you take out the one layer, okay, and replace the head layer with what you're looking for. Okay. You take the rest of the stuff which is already pre-trained on it because you don't want to build from scratch up. But you take ImageNet and you convert, you update one layer so that it serves whatever purpose you're looking for. Okay. So it's saying replace top layer for Mango versus non-Mango. Okay. Train on labeled Mango dataset. So that's what it's about. Okay. So we'll go into the details of transfer learning and all that in subsequent sessions. Okay. So today's session is supposed to be more for understanding what is computer vision at high level, what are the key stakeholders, who are the guys who are there, not there, and how you can actually take the data and try by yourself. Correct. So end of the day, you should be trying stuff on your own. That's when you get that real feel. Okay. So the next thing is object detection for counting. Again, we said we want to be able to, that's our problem statement. We want to be able to locate each plant in that particular image and say if it is mango or not, and then total it up and get the output. Okay. So again, what is the best way for detecting this? You can either use binary classification, simple yes, no, and then use object detection again for counting and mapping so that you're more clear. Because if an image has multiple plants, you have to make sure that you only count the mango ones in that. and then use a hybrid approach and all that. Okay, so we'll come to this. So before we go there, again, in interest of time, right? It's already 7:30. So there is again, to give you a better understanding, right? Since today's session is more of interaction and simple. So open this site called teachablemachine.google.com, guys. Everybody, all of you can open this. I'm just putting it in the chat here. Okay, open this so that you get a feel and flavor for what we are talking about when it comes to understanding teachable machine, computer vision. Okay, so all of you just open this. It's a very simple one. So click on get started. Okay, click on get started and click on image project. Then click on standard image model. Okay, come till here and let me know once you're here. Next, what I'll do is I'll share some data sets with you. These are the data sets from our field. Okay, you can open up these two data sets. One is Mango, one is non-Mango. Okay, open up both of these. I mean, I would like all of you to try doing this actually, because again, no point in doing a lot of theory. You guys can anyhow read on your own. Look at practical stuff and see how we are able to kind of implement it. Okay, so I'll open the first link over here. Okay, I would like all of you also to try doing this. It's not very hard, guys. It's not a lot of stuff, but you will understand and appreciate how how deep learning and machine learning, again, all this entire science helps us generate and analyze faster. So just select all of these images and download. Okay, so for the mango, so these are all mango plants, guys. So we have taken a drone and at a 10 feet height, right above each plant, so the drone just keeps going one after the other and takes the photo. Okay, now you see that most of the plants are not even. Okay, some of them are, look at this plant, it's so small, correct? Some of them are big, some of them are 8 feet, some of them are 3 feet, like, again, most of them will be between 6 to 8 feet. Okay, so all of these images, what you're seeing here, have been, some of them have been cropped to 512 by 512. Okay, now you see this, you see a lot of background, but still, again, your model needs to learn. Okay, so just download these images, all of you, mango or non-mango. Okay, so let me just open this is all mango images, mango plant images, non-mango images. So what we did is we segregated them. So on the field, you don't do that, right? You need to do this data pre-processing. Okay, so of all the images taken, so some of these, if you see, this is a can someone tell me what plant is this? This first one. What plant is this? Anyone? Let's see how many. Let's see your knowledge of plants is. Any guesses what plant this is? Yeah. Anyone? Looks like we don't have anyone who have experience in gardening or plants. Yeah. Any guess, guys? Okay. Okay. What about this one? This one is easy one. The second one. Okay, I don't know for some reason. Are you guys able to hear me? Give me a thumbs up, please. Yeah, okay. Yeah, okay, yeah, cool. So any guesses, anyone? Well, okay, let me show a simple one. Okay. What about this one, anyone? Yeah, no, it's not mango. This is a non-mango. All these images are non-mango, right? Any guesses? Yeah, this one. What is this? No, this is not Goa.
Sitapal.
Yes, it's Sitapal. That's right. It also has some Sitapal on it. Yeah, okay. So go ahead and download all these images, guys. Okay, once you downloaded these images, right, go to upload, okay, and choose images or from your files. Okay, so I'm selecting all the mango images here, Control A, and clicking on open. Okay, so it loads all the mango images. I think there are like 47 or something. Okay, and then I go to, so again, this one, and I select all the non-mango ones. I go to the drive, again, downloads, and I select the non-mango. Of course, we had less non-mango on my farm, also there less mango, non-mango. But anyhow, it's okay for now. Name the first class as mango, okay, and name the second class as non-mango, because again, we are not segregating between what are the non-mango ones. We're just saying these two classes. That's it. So we'll click on train model. Okay, so it will click on training. So I would like all of you guys to also try this. So it is training. Just wait for it. So it's training. It has its own set of epochs and everything. And so once it's done training, this is how it shows, guys. Okay. So right now it's confused whether I'm mango or non-mango. So let's remove webcam. So let's keep it as file. Okay, select file, and what you can do is pick any image. Okay, and ask it if it is mango or non-mango. Okay, so again, you can try it out on any wild image, but I'll just pick up one image again, whatever we have trained it on. So let's pick up some image over here. So it's clearly saying it's mango. Okay, let's pick up another image over here. This is also mango. Let's see by taking a non-mango and see if it's working. Let's pick again sitafal, right? Okay, so it's clearly saying 99% non-mango. Okay, so that means it's working fine, guys. It's great, awesome. So let's pick up. This is guava actually. Okay, so this is also non-mango. This is also perfect. But if you see, if I pick up banana, yeah, this is also non-mango. It's perfect, correct? So if you see that, right, we didn't really work too hard, right? This is. Anyone tell me what this plant is? Yeah, I don't know if you guys are able to see. Let me see. Just open it.
Lemon.
Yeah, that's lemon. That's good. That's nice. So that's lemon, right? So that's the beauty of it, right? I mean, I don't know if people are interested in agriculture or farm or plants and all. You love it. So I like it. I'm a small time farmer as well, so I like doing all this stuff. And I think it's also helps to solve a problem. So that's what gets me excited. But anyway, that's beside the point. I hope all of you are able to classify like this. Now, if you notice one thing about this, I have not written a single line of code. Okay, I've not written a single line of code. These images are totally new. I've not trained it before, right? Totally my farm images. Absolutely new images. Not even like it's been trained on Kaggle or something, right? So it's totally raw images that we generated. Now, the point is, without writing a single line of code, I've already built a model, right? As simple as that. So isn't that cool? Right, that's a benefit. That's a benefit of how deep learning helps to kind of help you do things faster. So Satvik has a question. Yeah, Satvik.
So the question is like, is it we have uploaded the already predefined image, right? Like whatever the image is from mango or non-mango, it's just identifying it from the data set we have already provided.
Okay.
So what if we provide something new, like from Google or somewhere? So we'll
Yeah.
be able to identify.
Yeah, sure. Why not? We'll try it out if you are. So you want to try it out? What you want to do? Papaya plant?
Yeah.
Okay, sure. Let's try it. Why not? So let's go for this one, right? This is the papaya plant. So save image as environment. Okay, papaya. Okay. So let's go for this. Let's go for this. Downloads. Papaya is here. Okay, so it's non-mango, working fine.
Yeah.
That's it. It has to work. I mean, there's no fun in actually training it and again testing on it. I only did that because I was a bit lazy. But what you guys should do is this: you should pick up a new image of your choice and see is it working fine. Correct. So maybe you should kind of look at also what is a borderline, like because I'm surprised it's working really well today. Because sometimes although you train it well, because the data set is so small, sometimes it doesn't get trained so well. Yeah, so you can try with your own images, and I would encourage you to do it. Correct. Because that's when you get the proof of the pudding, right? Is it really working fine or not? Correct. Yeah. Any other questions, anyone? So if you can pick up another thing also, let's say let's pick up something that's what fruit do you guys like? I don't know. So let's say avocado plant. How does it look? What does an avocado plant look? Okay. Yeah. So this is going to be tricky, right? So let's see. Avocado. Okay. So let's see if it detects it. I think it might say 50-50, but yeah, it's saying mango. It's in there. So again, I have not trained it on a whole lot of images, just like 47 images there and all, right? So if you train it more fine tune in terms of what it is, and again, one more thing you should notice is the angle, right? You train it on all vertical top images you've seen from the top, correct? This is a side image, so it's not really there. So of course it can make mistakes. So that's where the idea is, right? That's where we need see, end of the day, if it makes a wrong prediction, it's a wrong count, correct? You don't want that. So you also need to be able to say what is this model, accuracy of this model, right? Because I mean, how do I know it is working fine, not working fine, right? That's where metrics come. So for any model, you need to do evaluation of the metrics, evaluation of the model, and you have for different type of models, you have different type of metrics, correct? So again, for classification, you'll have the confusion matrix, right? And all the metrics are on there. You'll have your precision, recall, accuracy, and all those, correct? F1 score and all that. So again, they help us determine. So today, again, I didn't want to make it too heavy. I want to make sure that some of you guys actually show up tomorrow, right? So I didn't want to scare you with a lot of hardcore code and all that stuff. More for understanding what are we trying to do and how are we trying to do and what is the eventual goal, correct? The eventual goal is to build a model which will do exactly what I'm seeing here. I choose an image and it should be able to tell me, is that plant a mango plant or not? See, papaya again is working fine. So it's not an anomaly that is showing it correctly, okay? So I showed something else and, again, it got confused, right? So it's saying non-mango, although there's mango in that, correct? So that's what I'm talking about. Again, see, it said it's sitafal, it's sitafal, I think, over there. It's saying mango, correct? So sometimes it can make mistakes. Again, this is not mango, it's saying banana, okay? And that's good. So again, see, end of the day, building a model itself is not alone. You also need to be able to be sure about what is the accuracy of the output that's giving, correct? Because sometimes you don't go and verify every single thing, right? If you were to verify every single thing, then why the hell do you need a model for, correct? You would rather check it yourself. So you'll have to trust it after a certain point and say, fine, this is good to go for production. But what is it that determines whether I can go for production or not? That's metrics. What are the metrics we're going to use? How we're going to use? We're going to check it out in subsequent sessions. Okay. So we are going to use ImageNet for ours. We're not going to, directly use any other CNN or anything. We'll use ImageNet and try to build it. I'll show you in subsequent sessions how we'll do that. Today's session is more about you getting a feel of what we're trying to do. So I would like all of you to actually try this out. Okay. Okay. Any questions, anyone till here? Yeah. So yeah.
Hello. So most of the time we don't have label, right? Like here we know it's a mango and which are not mango. Like in a real world scenario, like you mentioned the Mozambique farm. But the farmer is trying to know, let's say I'm new to the farming, I bought a farm and have flown my drone, but I don't know how to classify. Like here we have labeled these are mango samples and these are non-mango samples, and we are classifying according to them. But coming from my understanding as a new person who is new into this farm and everything, but how do I know like it's a Mozambique plant or anything?
Say if you are farming, I don't know, if you can't buy a farm just like that, right? It's pretty expensive. Okay. So it's pretty expensive to buy a farm, right? So if you're buying it by spending like 50 lakhs, you better know what plants are there first of all, right? So you don't want to buy the farm and then figure out what plants are there, right? Nobody does that. So I don't think that's practically possible what you're saying. So you would know that you bought a Mozambique plant, but the point is, again, when I'm talking about mango versus non-mango here, the important thing you should understand is I'm not interested. See, most farms will not have like this. See, mine is a small farm, which is more of my passion farm, right? So that's why I kept, sitafal, guava and papaya and all, all the other, pomegranate and all. But most professional farmers, they don't do this, right? They don't keep an assortment of plants. The problem statement there would be, if there is no plant there, it will be empty. Correct. So when the drone goes and takes an image, it goes, it goes in specific slots. See, farms are all organized. Okay, they have specific slots where they're planted. Nobody just plants randomly. Okay. So if you see, I'll show you one data set. Data set. Yeah, if you see here, this is the data set. Okay, this is image 2. Okay, so this is how the aerial view of the farm looks. Whatever we are looking right now, this is the aerial view. Okay, flown at around 100 feet. So if you see, this is how they're all in a sequential manner, right? In a series. So if you see, there are no plants over here. If you see, this plant is missing here. You guys can see my screen, right? This plant is missing. Why? It got damaged. Okay. If you see, this plant here is very small, right? That means it got damaged and it is trying to just grow something, correct? But if I wanted to yield from a farm, I should have plants of the same height, pretty much of the same, because they're all planted at the same time. So either I replace this or I do something else. Now, if you see here, there are no plants here. 2 plants are missing. They got damaged, right? So the use case for us is not mango versus non-mango. The use case is either a mango plant, yes or no, right? Now, if it is not there, I don't care if it is empty or it is non-mango or whatever it is not there. So I want to know how many mango plants are there so that we can do estimation better, correct? So what do we need to estimate? We need to estimate how much pesticides to use, how much organic material, manure we should get, and whatever other inputs are required for each plant, right? Like if you need to put support sticks, how many support sticks are needed, correct? And all that is needed, right? So to do that calculation, we are looking at. And also, it's important to see how many healthy plants are there, because as season progresses, some plants can die due to get damaged due to weather, right, or due to chemicals. So a lot of you guys, I don't know how much experience you have. A lot of chemicals are put at various stages of a plant, like even Mosambik, they put chemical just for the flowering. Okay, so if you people thought everything happens just naturally, it doesn't happen that way. Correct? They force the plant to flower. So they use some technique where they apply a chemical so that the plant's roots are completely dehydrated. The whole plant gets dehydrated because of the chemicals. They suck out the water from the plant. So the plant becomes very dehydrated. I think it's hydrobenzene or some benzene something. So and then they pour water. So whenever they want the plant to flower, they pour water and the plant feels that it is suddenly got a fresh lease of life, it starts flowering. So again, this is just one technique, but there are a lot of such techniques that farmers use to get more yield, right? Because for a farmer, getting yield is the most important thing. So in the process of applying chemicals, some plants don't take it. They cannot sustain that chemical pressure, right? So they die or they decay. So this drone activity is supposed to find out which plants are still there, not there. And if you have over applied it in a lot of plants, then you better be careful, right? It gives you an alert. Today, what happens is farmers, when they go through the entire process, right, they wait till the end of the season. So a farmer, I know the farmer I'm talking with, he was expecting 10 tons, but he got 7.5 tons of yield, correct? Now you will only get to know that pretty much at the fag end of the season, right? But what we're trying to say is, again, if you know that number of plants have reduced, obviously your expectation also should be corrected, correct? Automatically. So of course, we will be doing more mini projects to solve other problems which we have along the way. There are several problems, like, again, next problem is pest and disease detection. Next problem is how much you have to determine yield using AI, correct? So that's a pretty complex problem to solve, but we'll do that. That is also computer vision, right? We'll come to solving more problems in subsequent sessions. This week, 5 sessions, we're going to do only one simple problem, which is you building using a pre-trained model to kind of detect how many image plants are there in a given image. Okay, is there a mango or not? And loop in all images and get the count, right? The other thing what we'll also do is geotag location. So each plant, if you zoom in, it has a particular location, correct? So each plant, I also want to know what is the latitude and longitude of each plant, right? Why do I need to know it? Because I will use precision farming going forward. So if my next model which I build for pest and disease detection, if I detect there's a pest or disease, I'll use precision farming. I'll go and spray only one plant rather than everything. Cool. So again, there are a lot of use cases, a lot of stuff we'll do. But I just wanted to kind of give you a feel of what we're trying to build in today's session. Tomorrow onwards, we'll get a little bit deeper into how you use ImageNet, how do you install it, how do you run it. Again, very small piece. Okay, we'll just do a very small piece. I'll explain just that much, and then we'll move on. Okay. So I cannot cover everything of everything, but do one small thing and do it really well and be really good at it. And if you sit in an interview or anywhere, you should be able to answer any question that comes. Okay. So that's the funda. Okay. So let's just continue and let's look at what else we got. So I share you the data sets. It's open for all of you. You can just take it. The take-home assignment for all of you is I want you guys, whatever teachable machine you built over here, I want you guys to kind of export this and use TensorFlow to actually run it in your own browser. Okay, you can export this model. You can see here, you can actually export it over here. So I want you people, as a homework or takeaway assignment, export this model and run it in your own browser where you can provide an image and it tells you if it is mango or not. Just like this classification is happening. Here it's happening over here because it's inbuilt into the teachable machine, but I want you to download this model, export that model and try it out on your own. Okay, that's a takeaway project for all of you guys. Try it, give it a best shot. We'll discuss tomorrow. Okay, and yeah, so pretty much that's it for today. I wanted to keep it small and brief and simple. Thanks for joining. Again, we have this dashboard, what I shared here. You can just scan it if you want. It's the same link which I mentioned. It's at alumnex.com/projects, right? Project-school. Yes, the recording will be available, Mahindra. Okay, at I pinned this particular link here, right? alumnex.com/project-school. So it will be available once this recording is available. Okay, it will take some time for it to come. Okay, so project-school. So you guys, it's already pinned over here, guys. I hope all of you can see. Yeah. So any questions, anyone? So that's about it. I don't want to kind of boil the ocean. It should be simple and sweet. You learn a little bit every day. That's more than enough, rather than making you PhDs on day one. Okay. Useful, guys? Any questions? Yeah, was it useful to you guys?